Hi Diksha Didi, good evening.
Hi everyone.
Right, so today we are going to continue with our functions only. So we saw the basics of functions, and today we are going to learn about the return statement in C++, right, and further. Right, so
Okay.
we are on this chapter, so let's just get started. Great. So the return statement returns the flow of the execution to the function from where it is called. So from wherever you call the function, the return statement will return the flow to that place. So when you call the function, it enters the function there, and the return statement will give basically it returns the flow of the execution to the function from where it is called, right, from the function like main, right. So if the main function calls some other function like x, right, so it will go in, it will execute everything, then finally after the return statement, when it encounters the return statement, that will basically return the flow of the execution to the main function, right. So it will continue after the return statement is in after basically the return statement comes, then basically the function will end and the main function will continue uh, executing. So this statement does not mandatorily need any conditional statements, right. So you don't need to give any conditional statements to the statement, right. So it's not mandatory. You can return on some condition if you want to, right. Instead or you can just give it at the end of the program, end of the function, one of the same, it's up to your use case. So as soon as the statement is executed, the flow of the program stops immediately, right. So when the statement is executed, the flow of the program stops immediately. So basically the function is terminated and it returns the control from where it was called. So the return statement may or may not return anything for a void function. So if for a void function you may or may not return anything, right. So but for a non-void function, a return value must be returned, right. So for a non-void function, you have to give a return value, right. For a void function, it may or may not return anything for a void function, but for a non-void function, there it is mandatory to return a value, right. And here's the syntax: return expression. So here's how the return statement actually works. In the main function, we encountered this a function, right. So when this a function call, so when this is called, right, in this a function, what we are doing, we are calling this b function, fb, right. And in this fb function, before returning, we are calling fc function, right. So in fc function, what we are doing, we are calling the f function and passing it oops, right. And basically what this is doing, this is throw exception, right. But if this will happen on a certain condition, this fbfc, all of this will be called on a certain condition. So if for right now, let's just assume that this condition to call f oops function was not met, right. So then if this was not met, then basically the fc function returns nothing, right. So it will go, when the fc function has ended, the control of the program has come just after it on the next line. So over here the code will be executed, and then because we are returning nothing, we are giving void, right. That's why you just give the return keyword, or that wasn't also mandatory, right. But we are giving the return keyword to mark the end of this function, right. Then when this is returned, then over here after the fb call, the control of the program is the flow of is returned, right. So the execution is continuing from here, right. And then when all the work is done from fa and this is returned, then basically fa, after it will go after fa, right. So it will go after fa and continuing executing after fa, right. So what we were calling function inside function inside function, right. And in the end, when fc return, then fb could continue its execution. When fb return ended, then fa could continue its execution, and when fa basically ended, then main could continue its execution. One more example over here is, in our main function we are calling fa, right. Then on a certain condition fb is called, then on a certain condition fc is called, and in fc, if this condition meets, where we are calling f oops, right, and passing it oops, right, and we are throwing an exception, then after throw exception it directly comes over here. So now we are not encountering the return keyword in the end, we are saying throw exception. So this overall fa method got a error, right? So we are throwing an exception in this overall fa method. So because of the fa, after the fa method it went in fb, then from fb it went in fc, right? So in fc it found an error, so this whole fa call that was over here led us to an error. And when there's an exception from the try block, it ends the try block and goes in the catch block. So basically in try catch, what is happening in in the try block, you give some code. If that leads to an error, it will go in the catch block and execute the catch block. So over here, when fa was called, then fb was called, and then fc was called. So in fc it found an error, so that so it threw an exception, right? So over there, when an exception occurred over here in the try block, it went to the catch block, and then the catch block is executed. Great. So here were two types of programs. One was over here with no error, right? It was just going on a function which was further calling fb, which was further calling fc, and in the end fc returned, right? So fc ended, then after fc ended, the control came over here, and then fb ended, then the control came over here, and then fa ended, and then when the control came over here, it went on to call f next. And over here what we had, fa was called, in fa fb was called, when fb was called fc was called, and in fc what we had, we encountered an error, right? So it threw an exception, and when the exception was thrown, it exited the try block and came inside the catch block, right? So great. Right, so this was a simple flowchart on returning, how return works, right? So basically the return statement over here returns the flow of the execution to the function from where it was called. So it over here, when we were returning, it returns the flow of execution from where it was called, right? So when fc was called and it returned a value, right? So the flow of execution came over here, so it returned the flow of execution from where it was called, so it continued from here. Great. So now, methods not returning a value. There are several methods that do not return a value. So in C++, one cannot skip the return statement when the methods are of the return type, right? So if you basically, if you say int x, right, so you have to return an integer value. You can't skip the return statement. So the return statement can be skipped only for void types. So if you give a void type, it's not mandatory to give the return statement, right? You can go on without giving the return statement also, but it is always suggested to give the return statement, as the return statement marks the end of your function, right? So in void also, you should be like giving the return statement but without any value, right? So now over here we are going to look at some examples. So not using a return statement in void return type function. So over here this is the topic, not using a return statement in void return type function. So when a function does not return anything, the void return type is used. So when you are not returning anything, the void return type is used. So if there is a void return type in the function definition, so in the definition you give void return type, or in the declaration only you give void return type, then there will be no return statement inside that function generally. So generally you won't find a return statement in a function that has return type as void, right? But if you give the return statement inside here to mark the end of this function, then also it's completely fine. So over here what is happening, we have a print function, right, that is a void method, right? So it won't return anything, right? So now we are just in this function, what we're doing, we're just printing welcome to Geeks for Geeks, and in main function we are just calling this print function and returning 0, right? By default So you must have noticed, we should not, this is not a good practice, but when you don't give the return statement inside the main function also, that will also work. Why? Because this is, the return type is integer and it by default returns, right? So by default it returns, right, some value, right? So it's not mandatory, right? So it won't lead you to an error when you don't give the return statement inside this main function, right? But it marks the end, or it basically tells the compiler that this main function was successfully executed, and return 0 basically tells the compiler that it has reached the end of the main function, right? So we should always give return 0, right? So now when we call the print function, nothing was returned, right? So we didn't see a return statement also, and welcome to Geeks for Geeks is printed, right? We could have also given the return keyword over here, right? And that would also work, right? Right, so the return keyword also marks the end of the function. So using a return statement in void return type function. Now, right now what we saw, not using the return statement in a void return type function. Now we'll see using the return statement in the void return type function. So now the question arises, what if there is a return statement inside a void return type function like we gave over here? Since we know that if there is a void return type in the function definition, then there will be no return statement inside that function. Generally, there will be no return statement inside that function. But if there is a return statement, like over here, inside it, then also there will be no problem if the syntax of it will be, right? So if we give the return statement like this, right, inside a void function, there will be no problem. So this syntax is used in function just as a jump statement, right? So it's just used like as a jump statement in order to break the flow of the function and jump out of it. One can think of it as an alternative to the break statement to use in functions. So when giving return in void functions, it basically in return means a lot more just than a jump statement in functions like int return with int return type. So functions with int return type, when returning an integer, right, we can use that function as a value. But when using return in a void function, that is basically to tell the program that basically this function has ended, and it is also used as a jump statement, right? So like a break statement is used to exit a loop, right, in between of the execution. Wherever you give the return statement in your void function or any function, right, the program that function will end and the control flow will be given to the caller function. So over here we have an example, this main method where we are calling print. In print we are just showing welcome to Geeks for Geeks, and basically we're returning void method using the return statement, right? So we are just returning, right, and basically this is returning the control flow over here, right? So basically now execution will continue from here, right? Great. So now we saw two examples, using return inside a void function and not using return inside a void function. But if the return statement tries to return a value in a void type function, that will lead to errors, right? So if we try to return a value like return 10 inside a void type function, that will lead to an error, right? So we have this print function that is printing geeks for geeks, and we are saying its return type is void. When we call this print function, that will show welcome to that will show welcome to geek for geeks, and then when we do return 10, we have given the return type to be void, but we are returning an integer, so that will lead to errors, right? So because this function expected to return no value, right, but we are returning 10, right? So if we run this will either give us a warning or an error. So we are getting an error over here. In another compiler they were also getting a warning, but we are getting an error, right? So great, so we are getting this error. So we cannot basically return a integer, string, or any value in a void method, right? And we can just give the return keyword to mark the end of the function. We can just at max give it like this. Great. So now we are on methods returning a value. Now we saw void methods, that the void method returning using the return keyword, not using the return keyword, returning, trying to return an integer value, and so on. Now we are going to look at actual methods returning a value, like int method that returns an int value, string method that returns a string value, and lot more. So for methods that define a return type, the return statement must be immediately followed by the return value of that specified return type. So when you give a return type, right, you have this function, then you have to give the value that is of this return type. So if I specify int over here, I have to return an integer value. So if you have this sum function over here, we are taking in a, we are taking in b, right, and then we have s1, right, that is equal to a plus b, and then we are returning s1. We said that the return type will be an integer, and when adding two integers and saving it, s1 is also an integer, so we are returning the integer, we are returning an integer type variable. Now we have num1 equals to 10, num2 equals to 10, right, and then we have sum of sum, and then we are passing in num1 and num2. When it adds the two numbers, we get 20, and then it returns 20. The return value 20 is saved in sum of, and then we print the sum is sum of. So the sum is 20 we will get. Great. So now we are on parameter passing techniques. So before moving on to that, I'll just like to confirm if everything is clear in this chapter.
Yeah, everything was clear.
Great. So now we are on parameter passing techniques in C or C++. So these apply to both C or C++. So now there are different ways in which parameter data can be passed into and out of methods and functions, right? So there are many ways through which parameter data can be passed in the function and out of the methods and functions. Let us assume that a function b is called from another function a, right? So if you have a function a that is calling the function b, in this case a is called the caller function. So a is called the caller function that is calling another function, right? So a is known as the caller function and b is called the called function or callee function, right? So b we will call the callee function or called function that is being called, right? So a will be the caller function that is calling another function, and b is the called function or callee function that is being called by another function. So also the arguments which a sends to b are called actual arguments. So whatever arguments a passes to b, right, so when you give the values in the brackets of the b function, right, those will be called actual arguments, and the parameters of b are called formal arguments, right? So over here, what are these? Alright, so over here, this, if we have this geek function, so these parameters are called formal arguments, and then when we are calling the function, then these are actual arguments, right? Now we have some terminologies: formal parameter, actual parameter, and then we have modes: in, out, in, out. So the formal parameter, a variable. So formal parameter was over here, we just saw over here where we are receiving the argument values. Those are the formal parameters. So a variable and its type. So a variable, so over here they haven't given the type, but giving the type is mandatory over here, right? So variable and its type as they appear in the prototype of the function. So prototype of the function is where this is getting defined, right? So the parameter and so basically the variable over here and its type, right, and where it is shown in the prototype of the function, right, of the function or method, right? So they appear in the prototype of the function or method. So this is the formal parameter, right? So now the actual parameter, the variable or expression. So a variable over here, but we can also pass an expression. An expression is basically like 10 plus 2, 20 plus 5, and etc. So a variable or expression corresponding to a formal parameter, formal parameter, like val1 is corresponding to num1. So whatever we give over here, that is val1, that will be the value of num1. Whatever we give over here, val2, that will be the value of num2. So corresponding to a formal parameter that appears in the function or method call. So that is appearing in the function or method call, right, in the calling environment. So wherever the function is being called over there, so that is called the calling environment, right? So basically, let's summarize the variable or expression, right, corresponding to a formal parameter, right? So corresponding to a formal parameter that appears in the function or method call, that is appearing in a function or method call, right, in the calling environment. So in the calling environment. So next we have the modes. We have the in mode that passes info from caller to callee. So when we are calling basically from the a function, when we are calling b and giving it giving its parameters some values, then that is called the in mode. Next we have the out mode that callee writes values to the caller, right? So when callee writes values to the caller, right, so when the callee, like b, writes values to the caller, that writes values to the a, that will be known as the mode out. And then we also have in out, that the caller tells the callee the value of the variable, so it passes some values which may be updated by the callee, right, which may be updated by the callee, and then they are and then finally it writes values in the caller. So basically it's just a combo of in and out, that the caller tells the callee the value of the variable which may be updated by the callee, right? So the callee is over here. Let's just take the example of a and b. So the caller, that is a, tells the callee, that is b, so tells b the value of the variables, its parameters, which may be updated by the callee, so which may be updated by b further, and then it basically b writes the values to a, like in a, right? So we are going to see all of these with examples also. So here were just some terminologies, right? Formal parameter, actual parameter, and then in out and in out. These are just some terminologies. So now we are on important methods of parameter passing are as follows, right? So there are two major methods of parameter passing: passing by value, right, and passing by reference, right? So passing by values over here. So this method uses in mode semantics, right? So it uses in mode semantics. We are going to see basically like this mode, in mode, this it uses in mode semantics, right, where the caller passes info to the callee, right? So when we are passing the like some value to b, for example b is our callee, right? So when we are passing some value to b, that is known as in mode semantics. So changes made to the formal parameters, so changes made to the, basically we'll use simple language, changes made to the received value, right, do not get transmitted back to the caller, right? So whatever changes you will make will not go back to the caller. So any modifications to the formal parameter variable inside the called function or method affect only separate storage location and will not affect not be reflected in the actual parameter in the calling environment. So let's just see this, what is happening. So for example, we have a function, right? So if you have a function, right, in which you are getting some parameter like x, so you're getting an integer parameter x, right, and let's just say it returns void, right? So now in this function, what will happen when this is using the in mode semantics? So you in this, when you change the value of x to say 20, then the outside where you call, right, so from the caller where you call this function, right, and pass it like a variable y that was created outside, right, and y's value is 10, right? So you create a variable y, right, you pass this function that y value, and in this function it is accepting it as x and changing its value to 20. So now this x is different from this y, so this value change will not affect this y variable. So this is in mode semantics, where basically the passes info from caller to callee. The info is being passed from the caller to the callee, right? But whenever this info changes or anything is happening, then it's not reflected outside of that function. So any modifications to the formal parameter is x, so any modification to this uh, uh, so any modification of formal parameter variable inside the called function or method affect only the separate storage location. So this x has a different location from this y variable, right? So it will only affect that separate storage location. It will only affect the local variable x, and that will not be reflected in the actual parameter. The actual parameter is y, so the change will not be reflected in y in the calling environment. So this method is also called call by value. So over here what is happening, we have a function and we are calling it, right? We have geek func, we are calling geek func and passing it val1 and val2, right? Val1's value is 10, that is corresponding to num1, and val2 value is 12, that is corresponding to num2, right? So now val1's and val2's copies are created, right? And that copy that 10 value, so num1 is a copy, right? So it's not pointing to the same memory location as val1. Num1 is a copy of val1 and num2 is a copy of val2. So this is the statement calling the function geek func, right? Val1 is 10 and val2 is 12. Then a copy of the val1 and val2 variable is created, and then geek func works on the copy of val1 and val2. So this works on the copy of val1 and val2. So when we change the value of x, when we change the value of y, so basically these are not x and y, right? So when we are just creating two variables x and y, so whenever we'll change the value of num1 and num2, as these are copies only, those won't be reflected on reflected outside. So val1's and val2's value will remain 10 and 12 only. Alright, so over here there's an example also. We have this function, right? That is returning nothing, right? And which is taking in a and b. Basically what this is doing, this is just adding the value of b to a, right? And it's just printing the value of a and the value of b. Now we have x equals to 5, y equals to 7. We are passing x and y to this function, right? So a is x, right? So a is a copy of x, that is that is 5, right? And b is a copy of y, that is 7, right? So now to a's value 7 will be added, so a's new value will be 12, right? Note that won't be reflected outside, so a's new value will be 12, x value won't change, right? And when a will be printed and b will be printed, then we'll get 12 and 7. And in over here when x and y are printed, right? So when x and y are printed, we'll get 5 and 7 only. So over here a's value changed, but over here x value didn't change, right? So a's value is 12, b's value is 7, but x value is 5 and y's value is 7. Now there are some shortcomings of pass by value also. So inefficiency in storage allocation. So basically you are again and again creating copies, right? You are again and again creating copies of the variable and more. Basically this inefficiency in storage allocation. For objects and arrays, the copy semantics are costly. So when creating copies of objects and arrays, right, then they may occupy big chunks of memory, right? So that may be costly, right? And that may be basically that may consume a lot of memory, right? So I hope pass by value is clear.
Yeah, it's clear.
Great. So now we are on pass by reference. So this technique uses in out mode semantics, meaning that in will give some value, right? And that change or any change will be reflected outside also, right? So changes made to the formal parameter do get transmitted back to the caller through parameter passing, right? So basically when there's changes made to the formal parameter, right, they do get transmitted back to the caller, right? So that those changes are basically, in simple language, those changes are reflected outside the callee function also, right? So any changes to the formal parameter are reflected in the actual parameter. So any change you make in the formal parameter, that is may also reflected in the actual parameter in the calling environment, as formal parameter receives a reference or pointer or to the actual data. So basically, when in passing by reference, you are actually giving a reference, right, or a pointer of the to the actual data. So you're, for example, giving the memory location, right, to the actual data, right, and that memory location the callee function works with, right? So that's one example, right? So when you are giving, for example, you're giving the memory location of your data that needs to be changed. So when you change that change in that memory location from the callee function, then that memory location is for the like for the same data, right? So that memory location that you give is for the same data. So whenever there is a change in the memory location, that will be reflected outside also. So whenever you pass the memory location and there's some change to the memory location, then that will be reflected outside in the caller function also, right? So this is also called call by reference, and this is efficient in both time and space, right? So we have this main function where we have n10, we have this function that is taking in a memory location, right, and naming it add, right? So add will basically have an memory location of an integer variable, and n is giving us the memory address of this n variable, so that is being passed to this function, right? So next, what we are doing, we are dereferencing the memory location that we have already done a lot of times, right? And we are going to do it once again also in the below example, and we are changing it to 20. So actual value, so this change that was here was reflected outside in n also. So actual value of n changes to 20, so the actual value of n also changes to 20, and now when n's value is printed, we will get 20. So here's an example, mostly passed by reference is most basic example is swapping of numbers, right? So let's see what is happening over here. So we have in a main function a10 b20, and we want to swap both the numbers. So we want a to be 20 and b to be 10. So we are passing swap the memory location of a and the memory location of b, that it is receiving in I and j. Then we are saying we are creating a temporary variable in which we are saving the basically the value, we are dereferencing the memory location, right, and saving the value of I in temp, saving the value of value whatever is there in the memory location that we are saving in temp. So now in I was the I has the value that is the memory location of a, so I basically has the memory location of a. When we dereference the memory location of a, we will get 10 that is saved in temp. So temp is saving the value 10. Then we are dereferencing I, right? So basically we are dereferencing the memory location of the a variable that was over here, and we are changing its value over here there to the value after dereferencing the value of b, right? So basically over here what we are doing, we are basically dereferencing I, right, and we are dereferencing j. When dereferencing I and taking it as a left hand side operand of the equals to operator, then what we are trying to do, we are trying to change the value that is there in this memory location of I, right? So now not of I, in the memory location that is saved in I. So I saves a memory location, right? So the value of the so when dereferencing the value of I, the value of I is a memory address. So when dereferencing that memory address, we are logically changing the memory where a's value is stored, right? So and then we are changing it to star j will give us will dereference j and give us 20. So 20 will now be 20 will now be saved in the memory location of a. So now when 20 is saved in the memory location of a, then a's value is 20, and then we are dereferencing j, right, and changing its value to temp's value is 10, and when we dereference it, right, then over there we are saving 10. So now over here in A, right? So I was A's memory location and J was B's memory location. What we overall did, we dereferenced A's memory location and saved the value in temp. Then we dereferenced A's memory location, and basically whatever value was there, we changed it to the basically to the value of B, right? And basically then we dereference the memory location of B and change the value of it to temp. So basically A's value is now 20 and B's value is now 10. And now when we print A and B, we will see that the changes were reflected outside the swap nums function also. So we are getting an error, fatal error, iostream.h. Alright, so let's just edit this code. I believe .h does not come here. Right, so A is 20 and B is 10. So I hope this example was also clear.
Yeah, was clear.
Alright, great. So now there are shortcomings of pass by reference also. So many potential scenarios can occur, right? So basically some basically unexpected results can also come, right? And many potential scenarios can occur, right? So many potential errors or scenarios can occur. And then programs are difficult to understand sometimes. So programs over here, if someone is new to programming over here and he or she reads this code, then it may be difficult to understand when working with basically memory, right? So directly with memory, and when we are doing pass by reference, then it may be difficult to understand. So what we saw pass by reference, we saw pass by value where the changes are not reflected outside, and then we saw terminologies. Formal parameter is the parameter that we are receiving over here in where we are specifying the function prototype, and there we basically give the parameters. Those are known as formal parameters. Actual parameters are when we are passing the value, right? So over here when we are passing the value, these are actual parameters. And then there are modes. In mode, when this info passed from caller to callee, right? And basically there's only in mode in this, that there's only info passed from caller to callee, and the changes to that info won't be reflected outside. Out, that callee writes values in the caller, right? So basically out mode we'll not see very often, where basically we are not passing anything, but that is but from we are not passing the function anything, but the function itself is changing basically stuff that is outside, right? So if you have a variable a outside a function, and we have a function that is directly, we are not passing it anything, and it is changing the value of a that is outside. That is the out mode, right? That the callee writes values in the caller. And then in out is that the caller tells the callee the value of the variable that may be updated by the callee, right? And the changes are reflected outside also, right? So this was in this chapter. Now we can move on to the next one. So in parameter passing, one more thing, we had this part over here, other methods of parameter passing. So over here there are some techniques mentioned over here, right? These techniques are older and were used in earlier programming languages like Pascal, Algol, and Fortran, right? So these are very old programming languages, and these are some techniques that were used in these programming languages. So when we will be doing some history of this programming language, or we are going to do some history of programming or something, then we can learn about these. So right now we're going to focus on the concepts that we are going to use right now in our programs, right? So now we are on difference between call by value and call by reference on this chapter, right? And this is going to be a very interesting chapter. Now there is less than a minute left in this class, so let's just continue in the next class.
Okay, thank you.
Thank you, bye.